So we've looked at finding the real roots of a polynomial, but we know from experience when we even factor a quadratic equation that we can come up with imaginary or complex numbers. So how do we handle complex zeros of a polynomial? Well, that's what we're going to talk about in this video. First, I want to show you what a quick example where you might see all types of zeros associated with it. Here we have zeros which would be rational in nature. I have irrational zeros where we might have things like a square root symbol. And then finally we have our complex zeros where we have the complex numbers shown. So we have all different possibilities for zeros that we are looking at. And one thing that I want to point out to you before we kind of get into our polynomials is kind of a review. Remember that we have complex numbers right here, that this 4 right here would be the real portion of my complex number, and the 5i would be the imaginary part of my complex number, and together combined the real and the imaginary give me a complex number. Another thing I want to make sure that you understand from imaginary numbers is I times I would give me I squared, but I squared is actually -1. So this is going to be important for us also when we're working on these examples. So we have this idea that says, and it's the fundamental theorem of algebra, which basically says that every complex polynomial function of degree n greater than or equal to 1 has at least one complex zero. Now understand that all numbers can be written as complex numbers. We just maybe don't see them that way. When we look at our roots, however, we want to basically remember, or we want to understand this idea about conjugate pairs. Okay, so if I have some complex number, a plus bi, as a root, then I will also have its conjugate, a minus bi, as its root as well. So basically, if I have any imaginary or complex roots, I will also have their conjugate as a root as well. So let's look at an example showing that right here. I have a polynomial of degree 5 whose coefficients are real numbers and have zeros at -2, -3i, and 2 plus 4i. So I need to find where the remaining two zeros are. So let's make a list. I know that I have a 0 here at -2. Well, that's a real number. I have a 0 here at -3i and one at 2 plus 4i. Each of these two roots are complex or imaginary in nature, so I need to make sure that I account for their conjugates. When we write a conjugate, we're basically just writing that same number with an opposite sign. So the conjugate of -3i looks like +3i, and the conjugate of this looks like 2 minus 4i. And there we have all 5 roots which this problem was addressing. So remember that complex numbers are the combination of a real and imaginary number, and again we want to allow for their conjugates as well when we are looking at the roots for these polynomials.